Alright students, today we're going to be learning about dihybrid crosses. This is a little bit different from what we've been doing. We've been doing so far monohybrid crosses, which means one gene, two alleles, and we use the Punnett squares with 4 boxes. Remember that? Now we're doing 2 genes, dihybrid, and this is one with 4 alleles, and now we use 16 boxes. So it's a little bit different. Let's take a look at that. Let's do a little sample. So I'd like you to turn to this handout right here. It's in your practice problem set packet, and it says dihybrid cross with this one. We're going to look at these problems right here. Okay, so really quickly right here, to do these problems, we look right here. It says heterozygous round eyes. Heterozygous round eyes, and then blue body. So notice that there are 2 genes. We're talking about eye shape, and I'll just label it here so you can see clearly. We're talking about 2 genes. Eye, that's telling us eye shape. And then blue body. So then the other gene is body color. Round eyes, and it's heterozygous. So we're talking about 2 genes, and so therefore each gene had 2 alleles, right? So 2 and 2, that's 4. So let's talk about heterozygous round eyes. Well, let's look at that. Where's round eyes? So round eyes. Right here, eye shape. And we know it's a dominant one, and it's heterozygous round eyes. So I'm going to put big R and little r. And the parent is also blue body. So let's look at body color. Little y, little y. So there you go. Little y, little y. Cool. Done. Then it says hybrid eye shape. Remember what hybrid means. Hybrid means mix. So eye shape. Where's that? Over here. Eye shape. And it says hybrid. So big R. Little r. And this is purebred round pants. Round pants is over here. And it says purebred, so it means homozygous. Little s, little s. So big R, little s, little s. And then it says purebred round pants. Purebred round pants. Little s, little s. Heterozygous long nose. Right here, nose style. So heterozygous long nose. So it's big L, little l. Alright, so now this is number 4. So SpongeBob's aunt, who is round pants. Okay, so let's look at that. Let's write out the parent. The aunt. It says she is round pants. I know I haven't finished reading the question, but I like to organize myself first. The aunt is round pants. That's what I'm given. And has a cute stubby nose. So that's one gene, round pants and cute stubby nose. Cute stubby nose. She's finally found the sponge of her dreams and is ready to settle down. Her fiance always comments on how adorable her nose is. He says it reminds him of his mother's. Oh, how sweet. They wonder what the chances are of that trait being passed on. So her fiance is a purebred. Okay, so let's write fiance, the dude, and he is pure. Excuse me, purebred, square pants, and hybrid for long nose. So hybrid long nose. Okay, so I got to look at my genes. Okay, now I'm going to go back up to the top right here. Remember this right here? Okay, and there it says, there it says that round pants, that's the body shape. So we're talking about body shape. That's the gene right here we're talking about. The other gene we're talking about over here is nose style. just so you know what I'm talking about. That's gene 1, that's gene 2. So let's look at body shape. This says round pants. So that was little s. Little s. So there you go. I'm going to use that one. So let's just list what they all are. So you can either be big S or little s. And that's square pants. Always write down what you're given. Little s is round pants. And then for nose style, you could be big L, which is long nose. And then little L, which is stubby nose. Okay. There we go. So now they're saying the ant is round pants. So she's little s, because that's the only form that she can be, little s. She has a big S, and that's square pants. Cute stubby nose. So stubby nose, little L, little L. See how we do that? And then the fiance is purebred, square pants. Pure, remember pure means homozygous, so pure square pants. So that means big S, big S. And then hybrid long nose. So hybrid long nose. So hybrid means a mix, so heterozygous, right? So hybrid is big L, little L. All right, so we got it set up. Now, they ask us identify the genotypes of the aunt and her fiance. We did that. Aunt and the fiance. Now, what are the possible gamete combinations for each person? Okay, so these are going to be eggs, right? So I'm going to go ahead and do that. These are going to be sperm. Okay, so I'm going to go ahead and do the process of meiosis. Remember what we're doing here. This is the same type of problems we've been doing. Remember, we get the parents, we get the sex cells, right, or gametes, and then we fertilize. Okay, so this is the same thing we've been doing. Nothing new. Don't get scared. Okay, this is all easy stuff. Now we go ahead and look at that, and remember, we don't just segregate. You don't just put little s, little L, little L. That's a big mistake. You first have to consider that you have two genes now. So you don't just separate like when we had one gene. So you can put little s. You can't put little s again. Remember, they segregate like that. They go to different cells, loss segregation. But you could have little s, little L. You could also have this little s and that little L. All right. Then you move on to the next one. Little s, little L. And then little s, little L. So they're all the same, right? Okay, that was easy. Then over here we have big S. Okay, you can't have big S again because they segregate. But you can have big S, big L. You could also have big S, little L. Then you could have big S, big L, and big S, little L. See how I did that? So in reality, here's all it looks like one combination over here. Two combinations, either big S, big L, or big S, little L. Same stuff over here. All right, so now we have the sex cells. We have the egg and the sperm. Now they can make kids, right? We want to see what the kids will look like, what the possible genotypes of the children are going to be. So now we're going to use, because we have two genes now. So now we're talking about dihybrid, remember? Two genes, 4 alleles, okay? And 4 alleles. All right, so now I'm going to go ahead, and I usually just start drawing a big box like this. And then I draw a window like that. And then I go into it. And then, so however you end up drawing it is fine. Okay, so now I'm going to go ahead and put the sperm out here. The flagella over there. Eggs. Okay, so now let's go ahead and put them in there. Put the sperm down there. So I just copy them in here. S L, S little L, S big L, S little L. Over here, put them all. They're all the same. S little L, S little L, S little L. Little s, little L, right? Okay, so now we fertilize. Now be careful here, because students think that this is like some mystery how you do dihybrid, and they think it's harder. I don't know why, but to me it's still easy. Just keep in mind you're going to put all the S's together, all the L's together. Just remember that. So down and across, big S, little s. Remember, you put the capital in front for the same gene. Then go for the L's now. Put the L's together over here. Big L, little l. Okay? Down again, down and across. Big S, little l, little l. Big S, big L, little l. Down and across. Big S, little l, little l. Down and across. Remember the S's go first. Big S, little s. Right? Down and across. And then big L, little l. Go down across. Big S, little l, little l. Down and across. Big S, big L, little l. Now I'm doing this a little bit slow just so I don't mess up. Big S, little l, little l. It's okay to be patient on these because one mistake can cost you the whole problem on these. So you want to take your time and you don't have to rush it. And then big S, big L, little l. Big S, little l, little l. Big S, big L, little l. Big S, little l, little l. Down and across, big S, big L, little l. Big S, little l, little l. Okay, sounds good. We got it. Bam. So now they're asking us, what are the possible genotypes for the children? Well, let's look at the kids. And so we can do genotypic ratio here. Let's see. Big S, big L, little l. How many times do I see that? Well, there. Let's see. I also see it here. 2, 3, 4, 5, 6, 7, 8. Is that it? Yep, that's it. 8. Okay? Dot, dot. What's the next genotype? I go. You see what I did? I crossed those all out because I used them. I don't want to count them again and mess up. I used them. I crossed them out so I don't look at them anymore. Now I go to the next one to the right. I started with this one. I always start from top left to right. So the next one is big S, little l, little l. So I count right here. What do I notice? You know what? I don't even have to continue counting. I see a pattern. It just stands up to me. And I see 8 also. It's 8 of these and 8 of those. And so these are the genotypes that I see. There's really 2 genotypes for the kids. And I can stop there. I don't have to go into phenotypic ratio because the problem is not asking me that. So that's how you do that one right there. Now, next one.